Hey kids, today's lesson is relatively straightforward, but I do have to remind you about a couple things you probably haven't thought about for a long time, and that's inequalities and expressing inequalities and intervals on a number line. So we're going to start off with some really straightforward examples that are not in your notes at all. I'm going to move to this idea of interval notation, and then we're going to bust out the note packet and complete page 5. The whole process should take maybe 15, 20, 25 minutes, and then there'll be a short assignment for you to complete before we meet again on Thursday. So let's kind of just get to it. You know, when you guys were in middle school, you learned about inequalities. Maybe you saw a number line picture like this. You'd be asked to write an inequality for it. And I don't need you to be an expert at this. You know, I don't necessarily expect you to remember this perfectly. But I do hope that if I were to say, hey, an inequality for this would be the x values are all these x values over here, they're all going to be bigger than the number that's right over here. And definitely not equal to it. So we could say this is x is bigger than 3. You know, and that's familiar to you, right? You've done that kind of thing before. And sometimes kids get confused about which way the thing is supposed to face and all that kind of stuff. And here's the great thing. We have this new idea called interval notation that takes all the confusion out of which way this thing's supposed to go and makes it really simple to work with these types of situations. The problem is interval notation looks a lot like other stuff we've done in math. So if I was going to try to express this exact same idea, but I was going to use interval notation, here's what I would do. I would write down the leftmost number, which in case is 3, and I would write down how far over to the right it's going to go. Now this one just goes to the right forever and ever and ever and ever and ever and ever. It never ever ever stops. We have a word for that in math. When something never ever ever stops, we say it's going all the way up to infinity. So I'd also write next to this 3, I'd write an infinity. And I would put a round bracket on this side and a round bracket on this side. I would use a round bracket anytime this endpoint's not actually part of my answer. So as we can see on this first example, because it's a 3 with an open circle on it, 3 is not included in my answer, that means I'll use a round bracket. And then that's the smallest number that's on this number line, and this just keeps going forever to the right, so I go ahead and slap an infinity down to say, and just keep going. Now it seems confusing the first time you see it, and you're probably like, why would we do this when I could just do this? But trust me, as we get into the notes later on today, this interval notation, that's what this is, it just makes our lives really a lot easier. So let's think about this next example for a second. Now this time, the number is over here on the right, and I've shaded all these numbers to the left. So you can imagine some numbers that would be over here. You know, 7 would be over here. 0 would be over here, -10. And in fact, this goes all the way. It just never, ever, never stops. It never stops. So if I was to try to think about what's the lowest, smallest number that is being shaded in, well, it's all the way to the left forever and ever and ever. So we would start this off with negative infinity. And then this does have an endpoint here at +8. Nothing's higher than +8, so I'll say let's stop at +8. But one difference between this example and the previous example is that this 8's actually colored in. It's actually part of my answer. And so I would put a square bracket if that number is actually part of my answer. Now, were this middle school or freshman year, you would express the same idea saying x is less than or equal to 8. But that idea with interval notation is like, let's be as low as negative infinity. We'll never quite reach negative infinity, so we'll keep a round bracket. And then it's going to go as high as +8, but no higher. So I'll put an 8 with a square bracket. That's the same idea represented using interval notation. And this last one, usually if I ask kids, students like you guys, to write this kind of a statement for this kind of a number line, kids get really upset. Like, it gets really confusing. You can try it. Go ahead and pause the video and give it a try. See what you come up with. It's difficult when there's 2 endpoints. I mean, I do this for a living, so I know a fast way to do it. I always put the lower number on the left and the higher number on the right, and what's shaded in is everything in between them. So I slap an X in between them. And then I would say that whatever these x values are, actually I go back to my second grade math that the teacher taught me about the alligator that always wants to eat the bigger number. And I think if I had some random x in here, whatever it is, that alligator would want to eat the 8, not the x, because that 8's always going to be bigger than whatever x is. So I'd be like this. And whatever this random x is, it's definitely bigger than this 3. So that alligator would not want to eat that 3. That alligator would want to eat the x. So it'd be like this. But with interval notation, I just have to look at these two endpoints and say, what's the lower of these two endpoints is 3. Whoops, let me not put that there yet. 3. What's the higher of the two endpoints? That's 8. We're not going to include the 3 in our set because it's not colored in, so I'll use a round bracket. The 8 is part of my answer, so I'll put a square bracket. So this is interval notation for this same idea. And you're going to see me use interval notation in our notes today as we talk about intervals of increase and decrease. So if it's not 100% making sense, just kind of like maybe watch this video again and give it a try. And then as I explain in the notes, maybe it'll start to click a little bit. So let's see what the notes have to offer today. Please open up your notepad to page 5. We'll do those 2 examples and see how it goes from there.